Hello, my name is Tomasz Idziaszek, and in this video I will talk about solutions to Fast and Curious challenge powered by Codility. In this challenge we have n cities located along a road that goes from the west to the east. We are interested in the sum of travel times from every city to the easternmost city. We are asked how much we can reduce this sum by building one motorway on which travel is instantaneous. Let's analyze the first example. Without any motorways, the cost of traveling from city number 0 to the easternmost city is 11. The cost of traveling from city 1 to the last one is 7. And from the city number 2 to the last one is 3. So overall, the total cost is 11 plus 7 plus 3, so 21. But if we build a motorway from the first city to the last one, then the traveling time from the first city will decrease to 0. The traveling times for remaining city won't change, so the new total time will be 10. We can improve this time even more by constructing a motorway from city number 1 to the last one. Then the traveling time from city 1 reduces to 0, and traveling time from city 0 reduces to 4, since we can first go to city 1 and then use the motorway. This way, the total time is 7. The last option for constructing a motorway won't improve the answer anymore, since constructing it in city 2 requires traveling times for remaining cities to be 8 and 4 respectively. So constructing a motorway in city 1 is the best option, and the answer for this test is 7. Based on this analysis, we can already write a simple, though not very efficient code. We can try every possibility of constructing a motorway in some city X and calculate the cost of construction independently for every possibility. During the calculation of the cost, we iterate over all cities, and for every city which is to the left of city X, we add the cost of traveling to city X, and for every city which is to the right of city X, we add the cost of traveling to the last city. Since we are iterating over all n cities when choosing a motorway, and then for every choice when calculating the cost, the total time complexity of the solution is n squared. So let's move to the implementation. First, let's create a variable for number of cities and the variable which will store the best solution so far. Since the length of the roads is at most 10 to the 9 and we have at most 10 to the 5 cities, the maximal possible answer will be 10 to the power of 14. And now we are going for every possible choice of the motorway, and we will calculate the cost of this motorway. And so we'll go for every city, and if this city is to the left of city X, or it is exactly city X, we'll just increase the cost of going from city I to city X, and else we'll just increase the cost from going to city n-1 from city I. And after calculating the cost, we'll take the minimum from the best cost so far and the calculated cost. And at the end we return the best cost, but we need to return the remainder of this cost when divided by 10 to the power of 9 plus 7. Okay, let's run the tests. So when tested by Codility, this solution will get 4 points for correctness, but not for performance, since it is n squared and n can be up to 10 to the power of 5. In order to speed up our solution, we can, rather than calculating the cost for every choice of motorway from scratch, we can calculate how the cost changes when moving the motorway from city X to the next city to the right, so city X plus 1. Well, we can see that now from city X plus 1 we can travel to the last city in 0 time. So the cost will reduce by the traveling time from city X plus 1. Moreover, the cost for every city which is to the left of X plus 1 will need to increase by the distance between X plus 1 and X, since we need to cover the longer road for the beginning of the motorway. We have X plus 1 such cities, so the cost will increase by X plus 1 multiplied by the distance between city X plus 1 and X. Finally, the costs for cities to the right of X plus 1 won't change. So if we will iterate over all candidates for the motorway from left to right, we can update the cost of constructing a candidate in constant time. So overall, this solution will have linear time complexity. And the implementation is also quite simple. First, we will calculate the cost of putting a highway in city 0. So for every other city, we need to add the cost of traveling from this city to the last one. And this will be our first candidate for the best cost. And then we iterate for every other candidate. So we change the cost for building a motorway in city X to city X plus 1. So first we decrease the cost by the traveling time from city X plus 1 to the last one, and we increase the cost for X plus 1 cities which are to the left of city X plus 1. Right, and we select the minimal cost and return the best cost modulo 10 to the power of 9 plus 7. Run the tests. And this time this linear solution will score full points both on correctness and performance.